I'm John Fasella. I was past president of RCA, and for 4 years now, I've been doing these interview series every quarter. It's a lot of fun, and we meet interesting people. Tonight, we're going to delve into the world of radio broadcasting, and I have David Layer, who's the VP of Advanced Engineering at the National Association of Broadcasters. And he told me he's, quote, the radio guy for the last 30 years at NAB. So the radio guy is going to talk to the radio club and other wireless type people watching. So, and for those of you that are new to this, we will record this. It's being recorded, and it will appear in about a week on our RCA YouTube channel, as have all the other interviews that we've done for the past 5 or 6 years. I went back and looked at those myself today. So without further ado, David, could you tell us a little bit about yourself? Give us a brief bio, please.
Hi, John, and thank you for asking me to come and speak with you tonight. We'll see how interesting it is. I mentioned before we started, I'm more used to being an interviewer than an interviewee, so we'll see how it goes. But so a little bit about myself. I've been working at NAB for 30 years. This was my 30th year there, and in my department, there's two guys in my department who have more tenure than I do. So I feel very lucky about that. I've really enjoyed working at NAB, and it's been a great experience. Hi, Barney.
Oh, Dave.
Hi, Barney.
Sorry, I'm about 20 minutes late.
Going
That's
way
okay.
back, I was born in North Carolina. My dad was going to school at the University of North Carolina, getting his PhD in physics. So, born there. We moved to Maryland when I was 6, and he took a job with the National Bureau of Standards, which is now the National Institute of Standards and Technology. And he worked there for his entire career. And I've lived in Maryland pretty much ever since we left North Carolina. I went to the University of Maryland as an undergraduate. I went to Purdue for a graduate degree, a master's in EE. Immediately out, and boy, back then, people were really hiring EEs. I didn't have any trouble finding a job. I had a lot of job interviews, and I wanted to stay in the area in Maryland, and it was not difficult. I worked when I was in school, I was a co-op engineering student, and I worked at a place called ComSat Laboratories, which is just not too far from where I live today, just outside the Washington, D.C. area. And I worked at ComSat as a co-op, and then after I got my master's degree, I went back to ComSat, and I worked there until I came to NAB in 1995. So I think maybe we'll talk about that a little bit more later. I have 5 kids. My wife Nora, who's my second wife, she has 6 kids. So between us, we have 11 kids. So that's something that keeps us pretty busy, especially around this time of year. And I don't know if I mentioned it, I actually live in Mount Airy, Maryland, which is about halfway between Frederick and Baltimore. And unfortunately, it's about 50 miles from NAB headquarters, which is in the heart of Washington, D.C., right near the Capitol, a block from the Nationals ballpark. It's a great location. I mean, if it were only a little closer to where I live, but so that's just that's a little bit of background for you, John.
Perfect. Thank you, David. You had mentioned you had a co-op internship at ComSat Laboratories, and that sounds interesting. Well, can you elaborate on that bit?
Sure. Well, this is when I was going to school at the University of Maryland. I started out as a radio, TV, and film major, which I wasn't really getting a lot out of. And after a couple of semesters of that, I switched to EE. And I learned about co-op engineering programs. And I thought that sounds like a great idea, because the way it works is you take time off, you skip a semester of school to go work at the co-op, the business that you're being affiliated with. So I worked I remember I'd work a semester, and like the spring semester and summer, or I'd work for the summer and the fall semester. And, so it took a little longer to get my degree, but it was really invaluable. I would encourage anybody who wants to be an engineer and study engineering to look into co-op engineering. I know a lot of people who have done that, and it's really worked out well for them. And for me, I I did the co-op engineering, then I went away to graduate school. I came back and I started working at ComSat. And ComSat was a really interesting company because when it was formed by an act of Congress in 1963, and it had a mission to create a global satellite system and a communication system. And it was a private company, but it had a monopoly on satellite communications into and out of the United States for many years. And because of that monopoly uh, business, they had a good bit of revenue, and they also, as part of the monopoly, they had to reinvest X percent of their revenue into research and development, and that all happened at ComSat Labs. So it was a really neat place to work.
Hmm.
And at the end of the year, they'd be throwing money at us and saying, "We've got to spend more money." Um, and we did a lot of interesting work. I worked in the modem design department, and we worked on, uh, which were at the time advanced modems for satellite communications. But all good things must pass, and ultimately, satellite communications were deregulated, and ComSat lost their monopoly, and had a very difficult time competing with other firms. And eventually, they were bought by Lockheed Martin. Excuse me. And that's about the time that I kind of jumped ship and I went over to work for NAB. So, but it was I like to say I was a real engineer back in those days. I was on a bench designing electronics. I did some really cool field tests of satellite systems. And, I had a really thick lab notebook, and that's a little different when I go to NAB to it's almost like a new career.
By the way, at that time, David, was ComSat, were their satellites primarily for telephone, long distance telephone calls, or was it TV? Because I know there was some early TV feeds from
Sure.
Britain.
Yeah, well, so ComSat didn't actually manufacture or own satellites. That was Intelsat, which was a treaty organization, and ComSat was the U.S. signatory to Intelsat. And Intelsat built the satellites and launched them and operated them. And I think video took over, and definitely telephony would be used over the satellite, but I think video, at some point probably became a bigger business for satellites. Um, but nowadays, of course, the satellites are, like C-band is something that we've been talking about here at NEB, and how the C-band satellite service is being basically replaced, I guess, by mobile something. And so it's just a changing world, and satellites are playing a different role than they did when I was at ComSat, that's for sure.
Yeah, we're going to get to that C-band stuff in a few questions. But let's just talk a little bit about the National Radio Systems Committee. They were developing a standard for digital radio in the U.S. What were the challenges in doing that?
Well, excuse me. The reason I was hired by NAB is because of my digital communications background.
Mm.
And it was in 1995 when digital radio systems were first starting to be tested. At that time, it was all analog broadcasting, primarily AM and FM, I guess. And it's before I landed at NAB in 95, it's interesting that NAB actually for a short time was a proponent of what you would call a new band digital radio system. It was called Eureka 147, and it's what turned into the DAB and DAB plus systems that are in use today, all around the world, and primarily in Europe. Now this system has the signal bandwidth, the single signal in the Eureka 147/DAB system is about 1.5 megahertz wide. So that's too wide. You can't take an FM band that's been channelized every 200 kilohertz,
Hmm.
drop 1.5 megahertz signals into that. So you need to identify a new frequency band um, in order to put up a system like that. And in Europe, I think it's band 3 VHF is the primary band that's used for the DAB services. Canada was an original adopter of that system, and they used the L band for their DAB service. But L band wasn't available for use in the US because it was being used for military purposes. And there was for a short time, NAB thought that would be a good system for the US, but very quickly realized that because it would need a new band and there weren't any frequencies. And the other thing they realized was this Eureka 147 system can accommodate very many audio programs, and it's what's called a multiplex. And radio broadcasters in the US would end up joining multiplexes and basically sharing the same coverage area. And that's something that commercial broadcasters in particular were concerned about because they invest a lot of money and time into developing their stations and optimizing their signals and, building out their plants. And they, in many cases, they feel like it's their competitive advantage, and they could see how this DAB system might negatively impact their competitive advantage. And NAB pulled out of that project, and that was the beginning of the in-band on-channel radio system development. And that's what the NRSC considered. And there were a couple of systems that were being developed. There was USA Digital Radio, there was Lucent Digital Radio, and there was a company called Digital Radio Express, which had a digital radio system that was actually going to be based upon FM subcarriers. And so the NRSC spent years looking over these systems and doing evaluations. And during that time, these three systems, they decided they were going to work together. And they basically merged. They created Ubiquity Digital Corporation, which today we know as Xperi. So, and the HD radio system is the system which came out of all that. And I I apologize if I got some of the details wrong there, but that's the gist of it. But it was a long, hard effort to test this system. It was both for AM and FM bands. There were some codec issues with the AM system as it was originally designed, and broadcasters basically said, we're not going to endorse this system unless you improve the audio codec. And they went back and they improved it. And we tested it again, and it was better. And ultimately, broadcasters did endorse HD radio. And it's been for FM broadcasters, HD radio has been a success, but for AM broadcasters, not so much.
Right. And this ties in, doesn't it, to the early experiments with AM stereo?
That would be quite a while before the digital radio revolution. And that was before my time working with broadcasters. But my understanding is that there were 4 systems put forward
Right.
that could do AM stereo, and the FCC declined to pick one, which really kind of meant nothing happened. And then eventually they did finally pick one. It was Motorola Sequam, I think. But it was too late. It was like a missed opportunity. And,
right.
And
I believe Harris had a system, excuse me, I believe Harris had a system, and also Leonard Kahn had a system, and he was actually an RCA member.
So, and then the HD radio development complicated things because HD radio AM signals are actually incompatible with AM stereo. So you couldn't do both. And that turns out, I suppose, not to be such a big complication because, as I mentioned a moment ago, AM HD radio has never really caught on. And there's only a couple hundred stations using it. if we talk, I may get a chance later to talk a little bit about something called all digital AM. And that's one of the HD radio AM modes of operation, which has been approved by the FCC, but it's not a mode that hardly, there's really one station in the US that is solidly behind all digital AM. And the problem is that there just aren't enough receivers yet to make it a viable service. I think that's fundamentally the biggest problem.
So I had a question for you about the move of some broadcasters from satellite to broadcast grade IP um, uh, video, and that there were some issues about latency, and you had made a comment to me that, of course, the latency with IP delivery can get worse, but it's also not so good with satellite. So you want to make a comment about that?
Sure. And I think just to be clear, John, when you say satellite, do you mean satellite like direct to home type satellite, or do you mean like satellite distribution of network content to terrestrial stations, that sort of thing? Because
I think I mean direct to home. I am not a broadcast expert, so you're educating me is a good thing.
so the broadcasters that NAB represents are all terrestrial broadcasters.
Okay.
We have, in fact, the requirement for NAB membership for a broadcaster is that they own an FCC license. They've been issued a license by the FCC to broadcast. And so the direct to home satellite stuff is not something that, NAB stations would get carriage, I suppose, like broadcast stations would get carriage on a cable system.
Mm-hmm.
But we focus on the terrestrial. And when I think about satellite IP delivery terrestrially, this is what we call over the top. This is where people have smart TVs that are connected to the internet. And you watch Netflix or, HBO Max or one of those streaming services. And the broadcast networks are certainly deep into that business. Paramount Plus is CBS's over the top streaming service. Peacock is the one that NBC has, and then Hulu is one that ABC has. So the terrestrial over-the-air broadcasters are into the over-the-top services in a big way. But as far as latency goes, my experience is that the over-the-top services, it'll be 5-10 seconds of latency between,
Wow.
say, if you look at an over-the-air version, and it varies dramatically depending upon how the signals are set up and what kind of coding is being used. And even with the ATSC, the ATSC 1.0 and 3.0 are the over-the-air digital TV standards we use here in the US. And here in DC, I can tune my ATSC 3 compatible TV to either the ATSC 3 version or the ATSC 1 version of a, say, WRC4 or NBC station here in DC. And just going between those ATSC 1 and ATSC 3, you notice 5 or 6 seconds of latency. So it's very processing dependent. And I don't think that it's not an issue that I think people are very focused on, but I could be wrong about that. I'm the radio guy. But unless you're at a sporting event watching a live broadcast, I mean, that's the place where latency is going to have the biggest impact, right? Because you're going to see the touchdown on the field, and then you're going to be watching your screen waiting to see the replay, and it hasn't even happened yet. So mostly, I don't think it's, as long as it's not, if it's in the tens of seconds, I think that's pretty manageable.
Okay, thank you. Some broadcasters are migrating from fixed on-premises infrastructure to cloud-based. What are some of the pros and cons of these moves to cloud-based, would you say?
Yeah, that's a really interesting phenomenon, and I have to caveat what I'm going to say by mentioning that even though I've been at NAB for 30 years, but I've never worked for a broadcaster. I've never built a broadcast facility. I have learned a ton, and in fact, I feel like my whole career is like standing on the shoulders of these broadcast engineers who I've worked with over the last 30 years, and learned so much from. And so what? And I've picked up on this transition to cloud-based infrastructure kind of in that way. And the main thing that I hear the broadcasters talking about is how this changes their budgeting from like a capital expense based thing to an operational expense thing. Because now instead of investing a lot of money up front in some equipment, you may instead just be paying a monthly charge to some cloud-based technology, which is, doing the same signal processing that you might have done previously with a rack full of hardware equipment in your transmitter shack. So I think that it changes the economics of it. And again, not having any experience working for broadcasters, I can't really speak to that, but I know this is something that they're very focused on. But in terms of like what's the difference in the technology? One of the biggest differences is that it really allows for a simple, redundant configuration. So when your station is hosted in the cloud and you can stand up the different instances of your station in different locations, so that if location A, say, is your main cloud location, if something happens to that and it fails, you can switch over to your backup location very easily. And
Does that imply different cloud providers or just cloud providers that have different physical?
I think the latter.
Okay.
And again, I don't know how broadcasters make these arrangements, but I would imagine if they have a preferred vendor for doing that sort of thing, that they're going to work with that vendor to establish whatever level of redundancy they need. But the other thing is too, ease of upgrading. We you know broadcasters are required to have equipment that works in the emergency alert system.
Mm-hmm.
And there's an encoder. It's a EAS encoder. There aren't hardly any vendors of this equipment, but all the radio broadcasters need it. And I don't work with the TV broadcasters as much on this, but when there's a upgrade required, stations, they have to like Clear Channel with what, or do I say Clear Channel? iHeart, with 800 stations ish. This is a major thing now. They have to go upgrade all their EAS boxes, and it's a tremendously time consuming and expensive from a labor perspective. But if you've got a cloud-based system, these things become trivial. They can be done, it's in software. So this is another one of the big advantages of the cloud-based technologies. And keeping in mind too that, well, it's not just cloud-based. It's also what you would, I guess, just call virtualization. So you can imagine running your virtualized system on a server that's actually on your premises. So it's not in the cloud. Maybe your backup is in the cloud, but you may, I think most broadcasters are doing this like an on-premises type of thing. So it's pretty cool. And I know that we have a test bed, a radio test bed at NAB, and where we can do, we have 3 FM and 3 AM transmitters, basically, just low power transmitters in 3 or 4 racks. Excuse me. And I'm currently upgrading our equipment to support virtualization because this is something we want to learn more about, and one of the things we do with our radio test bed is demonstrate radio and TV broadcast technology to government people or to our members or to visitors. So this is something that we'll be supporting, I hope, in the near future in our radio test bed.
Okay, thank you. That's illuminating because a lot of people are moving to cloud-based services, and that makes a lot of sense why in the broadcast industry it would be an advantage. I want to move to a different subject. You had mentioned ATSC 3.0. You have a TV with that technology. We first heard about this back about 5 years ago. Can you give us an update on the rollout and the user take-up of ATSC 3.0?
Yes, absolutely. And I want to share some slides.
Okay.
I'm going to go ahead and do that right now. Let's see how this works. And I want to offer some perspective. This is a chart, and I'll have to thank my colleagues at NAB for these slides, because again, I'm the radio guy and I have to go fishing for the good TV information. Here you see how the number of full power TV stations has changed over the last, a long time, huh? But this is how much spectrum is allocated for these stations. And what you see is back in 1970, you had twice as much spectrum as you did stations. And now jump to 2025 and it's way more in the other direction. And when we did the original transition to ATSC 1.0, it was pretty well matched. And because there was so much excess spectrum for that first digital TV transition, every television station got two channels. They got an analog channel and a digital channel. And they were able to put them both up. And then at I think it was June 9th, 1990 or something like that, when they shut off the analog signals, and then it was all digital. Well, now we have a new technology, ATSC 3, and we no longer have the option to give every TV station two channels. So the question is, how do you get to transition from what we have now, which is ATSC 1 to ATSC 3? And the answer is you share channels. And this is something that is being done on a market by market basis, where they figure out how they can combine a bunch of stations in ATSC 1 on one frequency, clear up space and on another frequency, and then start transmitting ATSC 3 services. And for a more concrete example, this is a fun graphic that we have showing how in DC there are these 5 stations. To make the transition, channel 33 put its video channels on another station, and then that freed up the channel 33 station to become what they call a lighthouse. So now all of these stations have a signal in ATSC 3 on the lighthouse, and they share the bandwidth. And the thinking is that, so now they have ATSC 3 signals in the market and ATSC 1 signals. And at some point, when there are enough television stations, they would want to switch over. And then NAB has made a lot of actually proposals on how to accelerate this transition to ATSC 3. And here's a map. And this is the last slide I'm going to show you, John, of the current deployment of ATSC 3 services. And you can see there's a lot of gaps still. And I think part of the concern some broadcasters have, I'm going to stop sharing now, is that the transition, how we're actually going to finally transition to ATSC 3.0 is still something that is being worked out, but there's rulemakings where this is being discussed. I know NAB has asked that the the FCC set a transition date, whereby after that date, everybody does ATSC 3 and ATSC 1 goes dark. But I think that that's still something that's being discussed.
So there is a date certain right now.
No, there's not. And at the current time too, there's something called the All-Channel Receiver Act, which compels television manufacturers to include VHF, UHF, ATSC 1.0 tuners into their sets. And at the present time, there's no requirement for television makers to include ATSC 3 technology. Many have Sony, Samsung, Hisense. LG had it for a while and is frankly a pioneer in many ATSC areas, but there were some patent disputes. And I think that at the present time, they have pulled their ATSC 3 technology out of their sets while they resolve these patent disputes. So there's still a lot of unknowns. Broadcasters are eager for this transition to take place. And we haven't talked about it very much. I saw flashing up on our Zoom screen here a little while ago a question about BPS, which is the Broadcast Positioning System. And that's a technology which can be used as a backup to GPS and which makes use of the ATSC 3.0 signal. So, that's
we'll give you a chance to get into that detail in just a moment here.
But yeah, so it's a work in progress.
Yeah, well, that's the way wireless technology is, isn't it? It's always a work in progress. It's always something new. I'm going to ask you one last question, and that was about mobile broadband. I know you were especially interested in that. So why don't you give us a quick overview about what that's all about?
Okay, I'd be happy to. Well, mobile broadband has become ubiquitous, right? I mean, everybody has a smartphone. Vehicles now, and radio broadcasters really focus on the radio receiver technology in vehicles because, especially in the US, most radio listening takes place in vehicles. The most important listening is there. And automakers for decades, generations really, right, have always included radio in the cars. And it's been great for broadcasters, it's been great for listeners, it's been great for automakers. Because these are things that people really want, and people continue to really want AM and FM radio in cars. But with the modern mobile broadband technology and the digital dashboard and connected cars, automakers now have other options for providing audio services in vehicles. And those include typically what automakers will do is they'll charge a customer for data services, and as part of the data services that they can get are included, limitless number of audio services. And I want to go ahead and share a couple slides again here as to show you an example of what this can mean for radio. And are you seeing this okay? This is a presentation I put together about radio and GM cars.
Yes.
I was just recently test driving these two GM cars. They're both 2025 vehicles. They're interesting because there's no HD radio in these cars. And this is a decision that GM made some time ago, was to take HD radio out of their receivers. And in the newer models, they're not including CarPlay or Android Auto either, which are both very popular services with consumers, and make use of mobile broadband. This is how consumers can take all the mobile broadband services, the audio services that they're using in their phones and project them onto the dashboard. So I was very curious to see how all this was going to look. The bottom line is pretty dire for radio broadcasters because the radio looks terrible, especially because everything else looks so good. And I'm just going to show you some examples. So here's the AM station list in the Chevy. I was looking at the Chevy and the Cadillac, and they're really pretty much interchangeable when it comes to this infotainment exercise. And this is the station list. It's not clear how it's generated. There's no control which you can say scan the band. So you can't, if you've moved, you don't know whether your station list includes all the stations or not. Here is what we call the now playing screen. This is when you're tuned to a station. And this GM car without HD radio, this is what you see. You see the frequency, you see some text information that's being delivered over what's called the radio data system. That's RDS. It's an FM digital subcarrier. So it's attached to the analog FM signal, and it's a very low capacity service. It's like maybe 800 bits per second. So it's not, you can't do a lot with it. Here's, by comparison, here's a streaming channel now. This is being delivered by mobile broadband to the car, and it looks fabulous. They have a huge piece of album art. They have buttons here. The arrow here is highlighting these buttons, which when you're listening to this content, you can push a button which takes you to some related content. And I can only imagine if this was a broadcast radio screen, if it was an FM now playing screen and you had those buttons, it would give a broadcaster an opportunity to direct their listeners to their podcast channel, or to maybe a archive of the morning show, or whatever it happens to be of interest to their listeners. Here's another example. This is a Pandora station that's being delivered by mobile broadband to the car. Here's the satellite delivered Sirius XM channel. And again, it's got the big album art. It's got the what we call deep linking buttons, which allow you to go to other material. And then here's another Sirius satellite delivered channel on the, I guess that was the Chevy. This is on the Cadillac. And so I'm going to just stop there, but you get the idea. These other services look fabulous. And they have a ton of, compelling things that are going to be of great value to listeners. And the radio just looks like something's missing. And this is a concern to me. And I think that part of the motivation is most likely because they can make money. The car makers can make more money with these other services. Sirius XM pay car makers a license fee to be included in the vehicle, I believe. So, or that didn't come out right, but they're paying to get their receivers in these vehicles. This is not something that terrestrial broadcasters could ever really do. I mean, Sirius XM is one company, and that's their business model. Is they get these receivers into cars and radio stations. There's over 15,000 radio broadcasters in the U.S. It's hard to imagine how radio could fit into that kind of a business model.
Yeah, it is a very different business model.
Yeah.
We're going to get to questions from the audience in a moment. I just want to change gears and do a quick infomercial. I hope that some of you out there were at the November annual meeting of the Radio Club of America. It was in Washington, D.C. I missed it myself for the first time in years, but I understand it was really good. And I know that people went to some interesting museums, including the Cryptologic Museum and so forth. So hopefully those of you that were there enjoyed those trips, which have been a feature for several years now at our annual meeting. I want to mention that the nomination for young professionals that we feat every year in the spring is due by the end of this month, December. And young professionals are rising stars in the wireless industry. It doesn't matter what vertical they're in, but they're somebody that's 35 or under, and they're going places. So please, if you know such people, go to the RCA webpage. There's a nomination section, and we ask you to put those nominations in before the end of this month. Barney Scholl, our RCA's general counsel, is now going to handle the questions that have been coming in. So please, either through the Q&A or the chat, please send us some questions. Barney, you want to pick one and get us started, please?
I will. There are a couple here that appear to be, I think they're very close together. Tell us about ATSC 3.0 and BPS, and would NAB consider getting LPTV stations, which I don't believe are NAB members, involved in supporting BPS as part of a comprehensive terrestrial precision geolocated timing and infrastructure as a complement to GPS GNSS?
So that's a great question, and I wish I knew more about BPS to do it justice. It's BPS, broadcast positioning system. It's something that was invented at NAB by my colleagues, and again, it's designed as a backup to the global positioning system, and focusing on timing aspects too, as much as more so, I believe, than location aspects, because precise timing turns out very important to, for example, the power grid. You need to, precisely synchronize the 60 hertz power grid. Banking transactions are entirely reliant, apparently, upon precise timing information, and that means that this whole, our economy is vulnerable to problems that might occur with GPS, maybe, intentional or unintentional. So this is something NAB is developing. We had a press release a week or two ago announcing that we're kind of we've created a new team to focus solely on BPS, because it looks like, it's really moving forward. We've got a big contract from the Department of Transportation to test out like the system. We're working with an industry infrastructure partner as Dominion Energy, I believe, and it's a system that's just at the beginning of its development. As far as LPTV stations, I don't know what the plans are for getting TV stations to participate in BPS, except to say that these have to be stations that are broadcasting in ATSC 3.0. So, and I know that ultimately our intention is that, all stations are using ATSC 3.0, and in that situation, it turns out you get extremely good coverage for GPS backup using BPS. So we certainly are doing our best to try and create I can see the question here right now, a comprehensive terrestrial precision geolocated timing infrastructure. And I don't know what the status would be for LPTV in the future. I'm sorry, I can't address that.
A similar, well, I won't say similar, going somewhat along the same direction. Isn't the rationale for non-cloud-based EAS to provide a wireless terrestrial backup when local fiber connectivity were to fail? He's thinking of an event such as happened in North Carolina during the flood when facilities lost services.
I'm not sure I follow in the question there, Barney.
Well, then we'll have to have that anonymous person try to refine that question.
I heard EAS in the cloud there mentioned, and that sounds like something we've been pursuing, which isn't so much EAS in the cloud, but just software-based implementations of EAS encoders. And our proposal would be that a software implementation could be deployed on site, like I mentioned earlier that stations that are virtualizing things often just do it on site. They have servers on premises, and that's where the virtualization is taking place. And that's the kind of virtualization we've discussed regarding EAS, not so much cloud-based, because when you start to involve the cloud, then there all kinds of security issues arise, and
well, actually,
reliability issues too.
The question said non-cloud-based EAS.
Yeah, well, I don't know what that could mean. The current hardware implementations that are required, broadcasters are required to have a hardware box for EAS right now. And that's creating some issues for radio broadcasters in particular. So we're looking we actually filed a petition for rulemaking to get the commission to allow a software-based solution, but I'm not sure if that's pertaining to your questioner's question or not.
Okay, moving on. There's a comment here about someone you might know. The director of ComStat was Dr. John Evans, who was also a famous ionospheric scientist, who was also the director of the Millstone Hill Radar, and was also a famous ham radio contester. He's 92 years old. Did you know him and have any stories about John?
Wow, I did know John Evans. He was the head of that, he was the director of the labs when I worked there. And I was a pretty junior engineer at the time. So I'm sorry to say I don't have a lot of stories about Dr. Evans, except I do remember that he had quite an impressive array of antennas on his property for his ham radio hobby. But I know we all had a lot of respect for Dr. Evans. It was hard for me to leave CompSat. I really enjoyed working there, and it was a really great place to work. Um, but I knew that with deregulation, it was going to change, and I reluctantly uh, jumped ship and went to work at NAB, and that worked out well for me, I have to say, because I've really enjoyed working at NAB for the last 30 years.
Next question. What is NAB's position on removing AM radio from vehicles? I enjoy that question because I bought a car about a year and a half ago that does not have an AM radio in it. But I still listen to through streaming, I still listen to one of the local AM radio
So
stations.
this means you have a Tesla, I think.
Yes.
Because that's one of the few. And so NAB has a very strong position on AM radio, and it's that it should be included in every vehicle. We've been lobbying hard with the Congress to get I think it's the AM Radio in Every Vehicle Act, and it was precipitated by the electric car companies starting to leave AM out, and our principal concern is that the EAS system that NAB's members participate in has AM as a backbone, and when everything else fails, the AM is still going to be there, and we feel like it's something that we need to preserve, and we're hopeful that I know that this legislation has strong support in both the House and the Senate, veto-proof majorities, I think. I'm not sure if that's actually, I know it's enough to get it to pass. So, but it's just hard to get things through the government right now. And we're very hopeful, though, that that will happen. And then, and because AM radio in electric cars is not impossible by any stretch. I have a Hyundai Ioniq 5, which is an all-electric, battery EV. Its AM radio works fine. So it's just a question of investment and what the car maker, I guess, thinks listeners want to have in their cars.
Yeah. I'll get this question out of the way. Dave, do you have an amateur radio license?
No, I don't. I'm embarrassed because it's, I've been surrounded by hams ever since I started working at NAB, and I've been intimately involved in the ham radio reception at the NAB show for over 20 years. So, but whenever I need a ham, I know where to go.
Yes. There's a statement here about WABC 770's owner is a big proponent of AM radio in vehicles.
Yeah, and their new WABC, I believe, is owned by, what is it? It's a radio company in New York. A good friend of mine named Burt Goldman just became their CTO, and they're definitely bullish on AM. Thank you, Red Apple Media. Yes, exactly. So we're actually working within the National Radio Systems Committee right now on an AM booster project. And Bert, through his work at WABC, has been involved. And it's entirely possible that we might do some booster experiments in New York with them. We're talking about doing booster experiments in Washington, D.C. as well.
There is a clarification of the earlier question that was stumbled over. My earlier question related to how the broadcast station obtains the EAS signal. I thought I heard you, David, say that the broadcaster would get its signal via non-wireless means.
No, in fact, this gets right to the heart of our AM radio legislation. The FEMA operates a network of stations called PEP, primary entry point stations. Actually, they don't operate them, the broadcasters operate them, but the government has invested money in these PEP stations to harden the facilities so that there's an emergency transmitter in like a nuclear hardened structure of some kind, and they have 60 days worth of food and water in these things. And it's really meant, if we really had to hunker down, these primary entry point stations are designed to be more survivable and to continue to disseminate emergency alert information across the country. And it's those PEP stations that are the prime, just like the name said, they're the primary entry point. And that is what and then it's a daisy chain relay between stations. So these are all, the broadcast DAS is relying primarily on broadcast transmission of the messages, not wireless, or not like broadband or anything like that. I hope that helps answer the question.
I'm debating which direction to go here, but after hearing some discussion when I was in DC a couple of weeks ago, comment about, do many people actually listen to AM in their vehicles? The audio quality is quite poor compared to FM, DAB, streaming, etc.
It is, and it depends on the market. You can go to markets where the AM stations are the top ranked stations in the market. So it's all about content. And this is, I've been on the tech side of broadcasting now for 30 years, and been talking to broadcasters about radio technology, and everybody wants a new radio technology that's going to help restore radio to its former glory, for example. But what really is going to restore radio to more greater prominence is content. And that's what, if the content is good, and if it's local, localism is the backbone of radio broadcasting. This is what allows it to stay prominent. And this is why, even though AM stations don't sound as good, they can still be ranked #1 in the market.
Thinking of I look at this as a question about quality of the signal. Can you elaborate on AM boosters? Is this like the European synchro stations?
Well, and when I say AM booster, I'm talking about an on-channel repeater. And I'm not familiar with the technology you reference in Europe, but FM broadcasters have been using boosters more and more. In fact, there's a company called Geo Broadcast Solutions, I believe it is. They have a system called Maxcasting, which does a great job of synchronizing FM boosters so that you can extend your coverage area, or fill in holes and things like that. So it turns out the FCC rules don't currently authorize AM boosters. So if we're able to do some AM booster tests later, in 2026, we'll need to be getting experimental authorizations. And if we do experiments that show that boosters really help, bring the signal up out of the noise and, improve coverage, then we would likely petition the FCC to amend their rules to allow for AM boosters. And that's kind of where our NRSC work would ultimately, that's kind of why we do stuff at the NRSC, is to ultimately impact the rules.
There is one question, a little bit broader question. What are some of the technical challenges facing broadcasters today?
Well, I mean, broadcasting is a pretty mature technology, right? I mean, so I think the challenges facing broadcasters right now are more along the lines of figuring out how to coexist with all the mobile broadband services, or how to make best use of streaming services for themselves. For AM, I guess the biggest, we did a study within the NRSC on noise in the AM band, and that's a big technical challenge for the AM radio service, is because of all the devices that we have, like wall wart chargers and LED stoplights, LED light bulbs, right, which have become very commonplace. These all generate RF interference, and especially in dense urban areas, they make it difficult to receive AM. It turns out this study concluded that the problem isn't so much that there's a high noise level. It's just that the signals aren't penetrating far enough into buildings and that sort of thing. So, that's a challenge for, getting broadcasters to accept some of the digital technologies like all digital AM, which is a great technology. I'm sorry, we're not going to have time to talk much about that, but it really works well. But it's just a really heavy lift to try and get listeners to, make sure they've all got digital radios. And if the penetration of digital radios right now in cars is on the order of 50%, if you go to an all digital technology, then half of the listeners lose access to your signal. So that could be, disastrous for a broadcaster. So that's just my sense is that's why they're reluctant to do this.
A non-technical question. What type of relationship is there between NAB and the IEEE Broadcast Technology Society?
So excuse me. Well, I've been at NAB for 30 years, and I've been working very closely with the IEEE Broadcast Technology Society personally. I've been on their board multiple times. I've been the chairman of their Broadcast Technology Symposium. I've participated in the Distinguished Lecturer Program, so very familiar with BTS. Formally, the most relationship NAB has with BTS is that they are a partner organization for our engineering conference. And that has meant different things over the years. In the past, they would actually do a little more than they're doing these days because of the nature of our conference has changed. But we work with them. They help us plan our technical program. And then they had a symposium at NAB recently. Well, not that recently. I guess it was a couple of years ago, where we were able to, give them the complimentary use of our space to hold their meetings. So those sorts of things and we give them a complimentary booth at the NAB show every year, I believe, too. So we're well acquainted with BTS.
Someone threw a little bit of a different one in here. TV broadcasters are moving to robotically controlled cameras and to virtually augmented reality studios. Pros and cons of these technologies?
Well, boy, I think my exposure to these technologies is completely limited to what I see on the NAB show floor, because this is not something that I'm involved in at all. And it sure looks cool. I mean, especially virtual sets. What they do these days with virtual sets is pretty amazing. And they seem to have been very widely adopted. I know I was watching some NFL football this weekend, and it was clear to me that, when the sportscasters get together before the game to talk about who's going to throw the most passes or whatever, clearly they're in virtual sets. So, the broadcasters like it. I think it looks good. I'm sure that it's got pros and cons, right? Because if you have robotically controlled cameras now, you probably don't need as many camera operators. So, maybe the camera operators don't like it as much as other people do.
But I wonder if it helps the creates more of audience or less of audience. I wonder.
I have no idea. I mean, broadcast TV technology is pretty darn good. I mean, we have such high resolution images. We have high dynamic range, video. We have surround sound. It's just amazing, I think. And I have a big screen TV in my family room and some, speakers all around. And I don't think that I've ever looked at something and said that robotically controlled camera just ruined my experience.
Okay, Barney, I think we're at about the end of it, right?
I think so. The question sort of slowed down there.
Yeah. Well, David, I want to thank you very much for a really interesting interview tonight. A lot of new technologies that some of us are very familiar with and others are not. It's our effort to continue to address many of the different vertical industries in wireless, and broadcast is one we haven't talked to in quite a while. So with your background, that was really helpful. Barney, I want to thank you again. And I want to remind everybody that the young professionals, please nominate a rising star who's under 35. Go to the RCA webpage. I also want to tell you all that sadly, this is my last interview. I thank you all very much for watching. But after 4 years and 16 interviews, I told Alan Spindell that it was time for me to hang up the reins and pass it on to somebody else. So the March interview presumably will take place, but there'll be somebody else moderating and hosting. So thank you very much, everybody. Have a happy holiday season. And remember that this interview will be posted on the RCA YouTube site probably in about a week to 10 days. Take care. Happy holidays to everybody.
Thanks. It's been a pleasure. Thank you very much.